How do I record performance monitoring? How do I record performance monitoring? Now, we're going to look at the we're going to look at on the moment we kickstart or when we are about to kickstart the performance monitoring. When a system has been commissioned, a system is about to run its operation. But prior to running operation, the user must know clearly what are the numbers he needs to look at on a day-to-day basis before he starts a system. Now, for an absorption filter, what is an absorption filter? An absorption filter, which is most of the time constructed of activated carbon, is to remove VOC, volatile gases, and certain type of acid and what's not, which is primarily for VOC. So what's going to happen here is now these filters are to tackle vapors or probably in contaminants in gases form. These filters, these air cleaning device is not made to remove aerosols or particulate matter. Aerosols comes in various types. You have particulate matter. Aerosols are anything which is less than 100 micron, which can get suspended, which can actually get into a respiratory, or when you get into a system, it can clog system because these are particulate matter. It can close pores. Now, if aerosols, particulate aerosols, especially particulate aerosol, or even maybe sometimes there's very uh, uh, liquid aerosol or fumes itself, which is type of aerosol, goes into an activated carbon, it will close its pores and it will clog the system. So what will happen is when that happens, you see, if you look at a system has, assuming that we have the filter panel around here, just right up to the okay, around here. So how the system functions is when a fan runs, the highest point of static pressure or the static pressure, yeah, of the fan is near of the system is near the fan. All right. Assuming we put a number, the number is 8. All right, the number is 8. Then this number will basically deteriorate, yeah, because this power is being used to to basically overcome all the resistance like friction of the pipe, the elbows, the fittings, and what's not, so that the system can still work to create exhaust flow rate of about, let's say in this case, 1619 cmh, example, right? So now, when we put a filter, the filter will automatically have a resistance. Of course, in this, when we design, we calculate the resistance. A bare filter, a new filter which is not clogged, assuming that it has a pressure loss of about 1 inch or 0.5 inch. Okay, example 0.5 inch. Okay, so which means that when a fan runs, if it's delivering 8-inch static pressure, 8 minus 0.5 is going to be 7.5. Okay, now why are we doing performance monitoring? Why are we doing performance monitoring? You got to understand, a system is designed to deliver this static pressure 550. Okay, this 550 is including of allowable pressure loss. Every filters have an allowable pressure loss. Now, again, adsorption filters are not designed to capture aerosols. Okay, so the allowable pressure loss for this is usually kept very low because its function it's not to capture dust. So which means that if it gets clogged, if the differential pressure goes up, that means we have to clean the filter. Why an absorption filter is going to get clogged? Mainly because since it's designed to capture gases and vapor, it is not designed to capture aerosols. If the room air is not it has dust. It is, I mean, of course, most of the laboratory is not going to run under clean room unless it is a clean room laboratory, right? So assuming that there is fugitive dust coming in and it goes into the system and gets into the filter will get clogged. So when the filter get clogged, what will happen? If it is within the allowable range, then it's okay. But if it goes above, for instance, the system can take up to 550. The 550 is inclusive of allowances, yeah. If it goes to 600, the flow rate will drop. When this flow rate drop, every performance will drop. That's the reason why we need, for instance, like here, I'll finish this example. Assuming that clean is a clean filter is 0.5. If it goes to 1, this is going to become 7. If it goes to 2, this is going to become 6. You see? So what we want to prevent if These increase to cause a very significant decrease of flow rate. That's what we want to do. So what do? We just keep recording this every single day until we see an extreme amount of drop, extreme amount of drop. Now, how to make this even more better? How to make this even more better? If you could actually have an anemometer. Okay, this is not mandatory, but again, that's why I said a bare minimum to start off is this. But assuming that if you have an anemometer, you can also take an anemometer reading, the phase velocity reading here. So this is correlating. So how does it work is, assuming that this goes up to 0.5, for instance, at 0.24, you get 100 feet per minute. Okay, anemometer reading 100 per minute. But at 0.5, this may go down to 79. So when this goes down to 79, what you're going to do is, you're going to stop the system. You're going to conduct maintenance. When you conduct the maintenance, it's going to bring back to, the condition of the system is going to come back to baseline condition. You keep recording, you keep recording. When you see this deteriorates, then you do maintenance. Now, again, the question is, what is this limit? What this limit? This limit, theoretically, this limit is the limit where the flow into the hood is so low, it will start, airborne contaminant will start going out and it will start affecting, it will start entering the breathing zone of the worker. All right. But for a start, we can start with 80 feet per minute because most of the time it is designed for 80. So we don't want it to go above 79. That is the benchmark. Okay, that's the benchmark. So we do 79 feet per minute. If you don't have that anemometers, you can start off by having about 0.4, so 0.5-inch water gauge. And take note of the system. If you have a smoke test kit, you can do a smoke test and see whether there is a tremendous drop. But do engage with the third party on a periodic basis to record these two data. Preventive maintenance is an ongoing data acquisition exercise, and you could understand the system better and you can implementing better. Preventive maintenance is not solely based on what your manufacturer tells. Manufacturer is only going to give you theoretical numbers, yeah. So that is why actual numbers by why preventive maintenance is very, very important. So I hope that covers the importance of preventive maintenance and how to record preventive maintenance and how to even make it better by using anemometer reading at the suction point. Thank you. Good day. Bye bye.